Thanks very much for joining us, ladies and gentlemen. We really appreciate your time today. We run these webinars regularly, and they give us a bit of an opportunity to sort of look at what we're doing with our aviation, look for opportunities to improve our safety practices, and really just have a look at what's going on out there and see if we can learn any lessons from what's actually happening out there. So today's webinar is to do with low flying. We talk about this because there are persistent inclusions in the accident statistics for low flying. We've seen a number of different types of accidents occur. They tend to be the same sorts of accidents, and today we wanted to have a look at those. And ideally, at the end of this, if you can go away from this webinar with maybe one or two things that you think there's something I could concentrate a little bit more on, or perhaps I've let my standards slip in that particular area, that would be a really positive outcome for us. For those who I haven't met before, my name's Craig. I'm one of the aviation safety advisors for CASA. I'm Perth-based. We have a team of 8 safety advisors around the country, based in every capital city. Different backgrounds. My background's pilot. We've got a few pilots on our team. We've also got engineers and air traffic controllers. And our role is to really do this, interact with yourselves, hear your concerns about aviation safety, give you some ideas on how to improve the safety performance in the industry, and generally just liaise with all of those aviators out there to help them fly safely. Generally speaking, we're doing pretty well in Australia. We've got a good safety record, but of the accidents that we see, and low flying accidents are one of those types, we see very common causal factors in them. And if we can address those causal factors, we can really have a dramatic improvement on the accidents that we do see. So yeah, keep your eyes open, ears open today. Hopefully you take away one or two things that will be of benefit to you. With the webinar format, there's a few little things we need to do to hopefully make it run a bit more smoother than it can do. These aren't as interactive as our online seminars, which we run regularly around the countryside, and I hope you've had a chance to get to one of those. What you will notice with the webinar is that your camera and your microphone are muted, and that's really just to help the whole thing run a bit smoothly, so the screens don't freeze, usually with me with some horrendous facial expression or something like that. So hopefully that'll make things run nice and smooth, and we can unmute your microphone if necessary, but we prefer not to if it's avoidable. If you're familiar with Teams, you can open the comments section on the right-hand side of your screen. So if you look up the top of the screen, there's a little speech bubble and it's labeled chat. So if you open that, basically you will be able to type in questions if you have them, and that's our preferred method. If you do want to ask a question, we'll be sort of addressing those questions periodically as we go along, and then at the end of the session, if there's any residual questions, we'll either deal with them there, or I've also put my email in the chat and you can email me and we'll follow up with any answers that you may need. So open the comments section, and that's a really good place to put your questions. If there's something really urgent you wanted to mention or ask, you can raise your hand. There's a little hand symbol at the top of your Teams meeting there. You can raise your hand and we can unmute your microphone and get your comments on your question. But as I said, the preferred method is really just to put it in the comments section and we can address it as we go along. I'll put various links in the comments section as well. I'll be referring to some documents. Some of them are regulatory documents, some of them are advisory, some of them are general information. I'll put those usually at the end of the presentation. They'll be in there. So if I am talking about one of the parts of the CASRs or any of the, say, safety material that the ATSB produces, I'll put those links in there and you'll be able to find them pretty easily. If you have any trouble with that, just email me and I can forward you the link individually. Also, what we like to do with our webinar series is issue it to the digital badge, if you would like one. So if you stay to the end of the webinar, we can issue with a little badge there, and that'll be in the form of an email to you. once the webinar is finished. And that little badge is really just a record that you've engaged in this safety forum with us, which is a really positive thing. Obviously, this one mentions that this safety forum was focused on low flying. You can use these badges in your email signatures, in your digital resumes, and your social media as well. So if that's of any interest to you, yeah, just look for that email at the end of once you've stayed to the end of the presentation, and you'll be able to grab one of those badges. So what did I want to cover today? Well, first of all, I guess we should frame why we're talking about low flying. Why do we gather you here to talk about that? We'll define what low flying is so we know exactly what constitutes low flying and what does not. We'll then talk about the regulations. It's important to understand those, of course. We will be talking about some case studies today, and a word on the case studies. Unfortunately, with respect to many accidents, in particular ones that are related to low flying, the outcome of these case studies is generally speaking fairly disastrous. It's not a pleasant thing to talk about accidents like that, but I think as aviators, it's a really important thing. We really need to work out what happened, extract the lessons, and apply them to our own flying. And sadly, in a lot of these cases, the pilots that were involved are not here to explain themselves or to give us their version of events. So we really have to just sort of draw conclusions from the evidence that we see in the individual incidents. What we don't want to do is sit here pointing the blame at people and saying, look, oh, I can't believe they did that. I would never do that. We have to admit that these were people, aviators like you and I, and for some reason they made these decisions that ended up in a really tragic result. We want to work out why that occurred and avoid that in our flying. So I don't want to cause any distress to anyone. The aviation community in Australia is a pretty small community. It's entirely possible that someone who's joining us today could know the people involved in these incidents, or perhaps have even been involved in the incidents. If that's the case, please feel free to just leave your computer for 5 minutes, go and grab a coffee, and rejoin us when you feel happy to do so. Hopefully today we'll be joined by our guest speaker, Phil Alavakis. Philip is a very experienced helicopter pilot with a lot of low flying experience, and he's going to give us some insights into some of his experiences and the incidents that he's had throughout his flying career. At the end of the session, we'll do a very quick summary, and at that point, if there's any unanswered questions that we have in the chat there, we'll address them, or if we run out of time, as I said, you can email me those questions, and we'll definitely get an answer to you. So, if you look at your screen at the moment, the bottom right-hand corner there, just to sort of start to paint the picture of the type of stuff we're seeing out there with respect to low flying and why we're talking about low flying. You'll see that Cessna 172. Estimated height there above the beach is about 70 feet. I think the 70 feet came off the altimeter setting, which was a photograph recovered from the aircraft. It looks a bit lower than that to me. This aircraft and these pilots had a history over a several day period of low flying when there didn't appear to be a valid reason for them to be low flying. This particular episode above the beach went for about 3 to 5 minutes. And I think we can all agree that you can see the shadow of the aircraft there. This is what we would constitute low flying, and in this case, illegal low flying. As is often the result, sadly, within 3 days of that particular photograph being taken, the 3 people in that aircraft were deceased. They hit a power line over a very remote part of a highway at 50 feet. None of the evidence from the accident site suggested any problems with the aircraft or the need to carry out a forced landing and the like. So this is a type of thing that we see out there, thankfully not common, but still the things that we really want to try and understand and work out. Why are we talking about low flying in particular? Well, if you've done any low flying, if you've trained in low flying, you'll know that it's a very hazard-rich environment. There are all sorts of risks associated with going at low altitude, even when we're actually trained to do it and when we're on an approved operation. So I think the first thing for us to admit to ourselves as aviators is that low flying is dangerous, even when it's done by competent people. There are risks associated, and we really need to understand what those risks are. Hopefully, if you're not already aware, by the end of today, we'll have reminded you of some of those risks. Perhaps there'll be a couple in there that you hadn't considered. The accident statistics that we see fall into sort of two broad types. We see low flying accidents that occur when people are illegally low flying, but we also still see accidents with people who are qualified to low fly. They have the approval and they're on an approved operation. And that's due to the nature of the high risk environment that it presents. So we talk about low flying today because the accident types persist in the ATSB data that we see. And we really want to try and make people aware of that and try and prevent them from making poor decisions in the case of illegal low flying. And in the case of lawful low flying, we want people to fully understand the risks and make sure they understand how to mitigate those to the best possible standard. This photo that we see in this particular slide is of an agricultural aircraft being flown by a pilot who holds a low level rating. If you just look at the landing gear there, you may be able to pick out the fact that the aircraft is actually touching the water. Despite the fact that the pilot is approved to low fly, this is not an approved low flying operation. And I think that's fairly obvious. The circumstances with this particular photograph, it's taken on a dam where a group of the pilot's friends had met to do some water skiing with a couple of boats, and the pilot had joined them and did a few fly pasts at the same time. I think a couple of hours after this photo, the pilot was very sadly deceased. He was noted as the as the people departed the skiing area, driving away in their car. He'd conducted a couple of very low passes over the cars and was last seen performing low-level aerobatic maneuvers in an aircraft that is actually not approved for low-level aerobatics. The pilot didn't hold a low-level aerobatic rating either. So this is another example of from the evidence we have available. It appears the pilot made a decision to low fly. In this case, you can't get any lower, and it resulted in a very tragic outcome. If we want to understand low flying, if we want to avoid falling into the trap of illegal low flying, we really, first of all, obviously have to understand the rules. And it's okay, there's a lot of rules associated with flying. It's okay if we get a bit rusty on those and we forget them. So don't beat yourself up if, I gave you a quiz right now and I said exactly what constitutes low flying. If you can't, sort of write that down, just admit that we're humans, we can forget things. We need to refresh our memory, and that's one of the reasons we're here today. So if you're a little bit hazy on what constitutes low flying, let's remind ourselves. First of all, the area we're flying over, we have to decide if it's a populous area or a non-populous area. The populous definition is pretty straightforward. If it's a very busy city, clearly that's a populous area. If it's a very remote area with no people in it, okay, that's not a populous area. Where the grey area comes in really is in between those two. For example, if you're flying over a beach in the morning, there's no one on the beach, it's a bit early for everyone, it's not a populous area. But a couple of hours later, when everyone's arrived for the day, set up on the beach, brought their eskies down, everything, there's quite a few people there, that same beach now becomes a populous area. So the populous area comes from effectively the Macquarie dictionary definition of it. So when you look at an area and decide, what's my minimum height over this area, basically what you want to do is look at the area, look for evidence of people in the area, and then think, well, if something went wrong and I had to do a forced landing or I lost control of the aircraft and it ended up on the ground, what's the risk to people on the ground? Is it a significant risk? If there's no one around, of course, there's no risk. There's a lot of people around, it's a huge risk. So just decide if there's a reasonable risk that your aircraft would injure or kill people if it ended up on the ground in that area. And that decides whether it's a populous or non-populous area. Once you've done that, you can work out your minimum heights. So what we're seeing on the slide at the moment is the minimum height for a non-populous area, and this height applies to both, and distance applies to both helicopters and aircraft. So it's 500 feet. And if you look down the bottom there, it's 500 feet within obstacles that are within 300 meters of your aircraft. So if you are below 500 feet of obstacles within 300 meters of your aircraft or helicopter, you are low flying. If it's a populous area, so there is a lot of people there, then that height quite naturally has to be higher to provide those people a bit of extra level of safety. And in this case, it becomes 1,000 feet. For an aircraft, it's 1,000 feet for obstacles that are within 600 meters of the aircraft. If you're flying below 1,000 feet above obstacles within 600 meters of your aeroplane, you are low flying. In a helicopter, it's the same height, it's 1,000 feet, but the distance comes down to 300 meters. So they're the rules. That's what low flying is. Can we be below those heights? Well, yeah, there are reasons that we can lawfully be below those heights. Otherwise, we'd never be able to take off and land, for example. So when can you be below those heights? That's a really important question. So you can when you take off and landing from an authorized landing area. If you're doing practice emergencies, you can be below those heights. There are a couple of provisos there, though. Obviously, with practice emergencies, we don't want to have passengers on board. And if you're going below those heights, you need the permission from the person who controls that land for you to do that, so that they're aware of the risk and that they can help you mitigate the risk to anyone that's there. Sometimes we might get weather events, poor visibility, etc. Particularly if we're a non-instrument rated pilot. Obviously, don't want to force ourselves into cloud where it can be even more dangerous than what we see at low level. So we might have to go below those heights if we've been caught out by weather, maybe an aircraft emergency, something like that. If we're circuit training, we're allowed to be below those heights. And of course, if we're on an approved air display with appropriate qualifications for the pilot and approvals from CASA, for example, for public displays, we can go below those heights. If you're in a helicopter, when you're hovering, when you're air taxiing, air transiting, ground taxiing at an aerodrome, obviously they're below those minimum heights we mentioned, and those operations are approved. I had a pilot one day at one of my seminars who had been chatted to because he went a bit low over a city. And he said to me, well, look, it wasn't really my fault. The council asked me to do this low fly pass for Anzac Day. So the pilot was sort of trying to shift the decision making onto the council, insisting that he do a low fly pass. That's obviously not going to work. Yeah, as a pilot in command, you're responsible for these decisions, and it's up to you to decide, first of all, am I qualified to do this? Second of all, is it an approved low flying event? And thirdly, have I done the appropriate risk mitigation to make sure it's safe? So you, in the end, are the person who makes that decision and are responsible. So there's a whole bunch of regulations about low flying because of the nature of the activity, because of the risk involved. If you haven't read them for a while, I really urge you to do so. It can be tricky to find, so I'll pop some links in the chat for Part 61, which is the pilot licensing side of things. Part 61Q is the particular part, and that deals with low-level ratings. So if you do want to conduct commercial or sort of semi-professional low-level activities, then you're going to need a low-level rating. 61.1040 to 1085 outlines all that, includes things like what flying training do I have to do to get a low-level rating, what aeronautical experience do I need, what are the flight test requirements. Then, because it's actually quite a difficult skill, there are also recency and flight review requirements associated with it as well. So there's recency requirements outlined in Part 61, there's flight review requirements, and you'll need to meet those as well before you actually conduct lawful low-flying activities under a low-flying endorsement. And of course, just the pilot being qualified isn't enough. You need to look at each particular low-flying activity that you're going to do to make sure that you've considered all the risks that are associated with that particular scenario and obviously appropriately mitigated those risks. So it's a multi-layered approach there to make sure that you are ready to go. Am I qualified? Am I recent? Have I got the flight review requirements? Is the activity approved, and have I done the risk assessment of it? It's quite a process to go through, and definitely something that you don't want to rush to make sure that you consider everything you need to consider. So what's going wrong out there? We've already chatted about a couple of case studies from the photographs I mentioned before. So what we've done is we've got into the ATSB data and we've extracted a couple of typical incidents that we see so that we can look at the causal factors mainly, and then hopefully you get a chance to think about those and go, have I fallen into that trap before? Have I been a bit complacent? Have I let my decision making lapse a little bit and got myself into that situation? So hopefully, we'll pick up things that we can do to avoid it happening to us is the main idea here. In our first case study, this is a really sad one. It's a Piper PA-28 Cherokee Arrow. It's a pilot plus 3 passengers. So the aircraft was flying over that particular dam, lake, I should say, that's Lake Eildon in Victoria, for anyone who might be familiar with that area. Witnesses around the lake actually noticed this aircraft. These are uninformed witnesses, so they're people who sort of don't know a lot about aviation, but their attention was drawn to the aircraft because of the extremely low height that it was flying over the water. So it looked low to people who really even didn't know the low flying rules. Very sadly, the aircraft hit a power line. Now, if you look at that lake from this picture, which is obviously taken from an aircraft, it would be almost impossible to pick a wire going across that lake. The wire that was struck spanned something like 2 kilometres. If you've been trained in low flying, you might just sort of pick the fact that there's a tower there and a little bit of a clearing where that power line goes, maybe down this way. You can see it's not an exact science unless you've done a proper survey and you know exactly where those power lines are. Unfortunately, in this case, that didn't occur. The pilot was a PPL holder and he didn't have a low level rating. This was a family sightseeing trip, and unfortunately the aircraft struck a power line 130 feet above the water. So if we reflect back on the low flying rules, I guess over that lake where there's not a lot of people in the immediate vicinity, you could probably argue that it's not a populous area, in which case the minimum height is 500 feet, and this aircraft has struck a power line at 133 feet. Clearly, if this pilot had simply complied with the low level flying rules, this accident would not have happened. I think the saddest part about this accident is one of the passengers was an 11-year-old girl. And if you think about accepting the risk of illegal low flying as a pilot, you're not only accepting those risks on behalf of yourself, you're accepting them on behalf of your passengers. And I think passengers have a right to expect that as a licensed pilot, we're going to exercise the privileges of our license within the rules. They don't understand the risks. Low flying to someone who doesn't understand the risks might appear fun, exciting, exhilarating. Unfortunately, they're probably not aware of all the things that can go wrong. The pilot is, and they are the ones that are responsible for making those good decisions. Please don't accept those risks on behalf of your passengers who don't know any better. When they got the aircraft out of this particular lake, they didn't find any evidence of mechanical issues. There was no valid reason they could find for the aircraft to be low flying. The 3 passengers' bodies were recovered from the aircraft, and the pilot's body in this case was not recovered, and he was presumed dead. So I think, you look at an accident like this, and as I said, we don't want to point the finger and say, silly person, I would never do that. This is a person like you and I, was an aviator like you and I. He didn't go out expecting for this to happen. We need to make sure that we learn from that incident and apply those learnings to our flying. The ATSB just simply could not work out why the aircraft was at low level. So they have to assume that it was a spur of the moment decision, maybe to give his passengers a little bit of a thrill, and it ended very badly. So that's a very straightforward one. Unfortunately, it's one that we continue to see. That's a type of incident we continue to see with that decision making. In our second case study, I want you to look for the similarities here as well. The similarities in decision making, the similarities in prevention methods for this sort of thing happening. This one involved a helicopter, Bell 206 in this case. There was a pilot plus 4 passengers. This pilot was a PPL holder, only 323 hours with 139 on type. So this is not an experienced pilot. So, to any pilots that have joined us today who are students or inexperienced, please fly conservatively. You have a lot to learn. It's a great fun experience learning and building your experience, but do fly conservatively. For those who are more experienced, don't think that makes you immune from these types of incidents. We see very experienced pilots fall into the traps of this poor decision making as well. This particular pilot did not hold any low-level endorsements. It was a joy flight. It was a friend's birthday party, and it was at a farm. So people in the party, they observed the aircraft flying over the property, doing low passes with these passengers on board, 100 feet AGL. Again, think back to the low flying rules. At the completion of one pass, the helicopter was seen to maneuver, bank steeply to the left. It rolled out, but then it continued descending into the surrounding trees and crashed. Came out of the accident, one of the things come out of the accident investigation was that 3 of the rear seat passengers, only one of them had their seatbelt on. So we can sort of see a pilot who at the moment looks like is being low flying without a valid reason with passengers that aren't adequately secured. So we're seeing a chain of events here, which sort of leads us to believe that, you know, this pilot really needed to slow down, think about what they were doing, making sure the passengers were safe, making good decisions to make sure the passengers were safe. That is sadly how the aircraft ended up once it hit the trees. Miraculously, nobody was killed in this accident, believe it or not. There was no evidence of mechanical issues for the aircraft when the ATSB looked at the wreckage. They all sustained serious injuries, and due to the fact that 2 of the people in the back weren't properly strapped in, one of them was actually found outside the wreckage, which is obviously incredible that everyone survived. When the ATSB looked at the circumstances, in this case, they were able to talk to the pilot. They also found the aircraft was being operated 28 kilos above its max all-up weight. Again, another thing that sort of implies the pilot was rushing. They were, not taking due consideration to make sure the flight was going to be conducted safely. There was no valid reason for this pilot to be down at low level, and it appears that due to the aggressive maneuvering at low level, the pilot lost control of the aircraft and then simply did not have the height to recover it. So we don't, when we talk about low flying, we don't even want to think about, hitting power lines, hitting towers and the like. That's certainly one of the big risks. But we reduce our options if something goes wrong. If we get a small, sort of decrease in engine power, if, we get distracted by one of the passengers, all sorts of things, a gust of tailwind that slows our speed, being at low level reduces the options we have available to deal with that situation. So a lot of people go low flying on the expectation everything's going to continue working normally and be fine. Unfortunately, that's not a good assumption to make. So there are a couple of case studies that we've seen that are occurring out there. And unfortunately, if you watch the news, you'll see that we continue to see those types of accidents occur. As I mentioned, thankfully, not often, but we can avoid these accidents pretty easily with respect to illegal low flying by simply following the rules. So our guest speaker today is Phil Alavakis. He's a helicopter pilot with significant experience. I hope Philip's had a chance to join us. There were some issues just before we started. I'm just going to check that Philip is with us. If not, I'll continue covering his stuff. So I'm going to continue there, folks. Looks like Philip's having problems with his microphone. So Philip has done some extensive low flying, as I said, and he's got a couple of case studies that he's either been involved in a couple of them. So the first event is another helicopter event here in 1998. We do see quite a few helicopter events in the low flying scenario, and I think that's pretty understandable, right? Helicopters tend to operate at low level in various roles a lot more than fixed wing aircraft. So they do tend to have a disproportionately high number of accidents and incidents. Not that they're flying more dangerously, it's just that they do a lot more low flying. In this case, it was a R22 pilot only. And this was a commercial pilot with 1,500 hours and 1,000 hours on type. So whether it's low flying accidents or VFR into IMC or anything like that, we like to remind pilots that if you're experienced, don't fall into that complacency that, I've got a lot of experience, it's not going to happen to me. We know that's not true. And in fact, in some cases, that complacency can make you more susceptible to accidents. So in this case, we see, quite an experienced pilot, rated for low-level operations as well. And it was ferrying a helicopter from Sydney to Jandakot during the peak of a very hot summer. If I remember rightly, when I talked to Phil before this presentation, this actually might have been one of Phil's incidents that he was involved in. So this is a ferry flight, fairly straightforward, you would think. For anyone who's been across that way, it's a refuel at Ceduna Airport and then departing to the Nullarbor Roadhouse flying west. Again, very hot day out there, 38 degrees and very, very bumpy at low level. So about 10 minutes into that particular section of the flight, there was a very severe shudder. Not a good thing in any airplane, particularly helicopter, and the pilot felt large vibrations in the helicopter. So immediately thought, look, I think there's something wrong with the airframe here. Always a good decision in a helicopter, as I'm sure the helicopter pilots out there will agree. It's good to get the thing on the ground if you're unsure of what's going on there. So in this case, pilot decided to land in some cleared farmland, which was there. Did a bit of a recce as quickly as you can in that scenario, and that's a good idea. It shows the experience of a low-level pilot looking for the particular hazards that might catch you out at low level, and saw a homestead and saw a dam nearby. So set up into wind for the approach. The pilot had the homestead on his left and the dam on his right, and was sort of picked an area that was going to be suitable for the landing. The sun was pretty much overhead at this stage, so you know what that sort of lighting is like. The house and the dam are about 50 or 60 meters apart. Now, if anyone's done a lot of flying out in the countryside, done a low flying endorsement and done that risk mitigation strategy, you're probably getting a little few red flags here already. If you've got something like a house near a dam, there's always a potential for something to be there, and in this case there was. Final approach at about 20 to 30 feet. Phil, in this case, just managed to see the power line. It caught the sun, luckily, and glistened in front of him, and it was right in front of the windscreen. So this was a power line that couldn't really be detected from any sort of significant poles or anything like that. And it was really just, by Phil's own admission, pure luck that he actually saw the wire when the sun glistened off it. Thankfully, he just had enough time to avoid that one. It was a matter of seconds, really. And in this case, he applied power. And when I was talking to him the other day, he just says, "Yeah, mate, I just don't know. I don't know how I missed it. I thought it was going to hit it, but he didn't. So caught it just in time, and was very luckily missed it and was able to land the aircraft safely." So when Phil landed, checked the aircraft out, couldn't find any mechanical issues on the aircraft. There was effectively nothing wrong with the aircraft. So the suspicion is that just that low-level mechanical turbulence had been strong enough that it actually felt like some sort of problem with the tail rotor or control surfaces on the chopper, and incorrectly diagnosed as a control issue or mechanical failure. So that prompted the emergency. But as I said, if you are low flying or flying at any stage, things like that can happen, and you really need the time to deal with it. In this case, with time, Phil was able to sort of have a look at it, make some decisions, but even then still had to stay sharp, looking for obstacles, and luckily saw that obstacle before it became a problem. One of the lessons he wanted to extract and remind people of that is, if there is dams near homes, and as I said before, some people probably already experienced this, there probably will be a power line running between the two. Probably in most cases to run a pump to bring water back to the homestead. So having done a bit of low flying myself, you do get used to the more likely areas where you're going to see power lines. But the other thing you learn pretty quickly when you do enough low flying is they can be anywhere, and they can be in the most unexpected places. When we talk about that little Cessna we saw in the first photograph over the beach, one of the reasons they think that pilot was flying so low over the highway was such a remote area, and he didn't expect there to be power lines. And as luck would have it, sure enough, there was one. I think that one was at 50 feet. So yeah, we can't assume they're there. We can try and look for them and put the odds in our favor, but we can't assume that they're not there unless we can possibly identify them with an appropriate recce. Second event here is another helicopter event. This one occurred in 1999, another R-22, as I said. Given the nature of their operations, this is not unusual that we see a few of them appear. A pilot plus one passenger in this case. So PPL with 150 hours, very low hours pilot, was rated for low level operations, had 5 hours, which is pretty much the minimum in this case, and was using the helicopter for a business, supplying sort of services to mine sites. On this particular day, the pilot decided to go on a scenic flight with his fiancée, and the aircraft unfortunately crashed. There was no evidence of mechanical issues. The pilot sustained multiple serious injuries. He spent 8 months in hospital. Unfortunately, his partner suffered fatal injuries. When they looked at what happened, why did this helicopter crash? What they worked out, it was being operated at low level flight. In this case, 70, 80 knots of the accident, so it was about 150 kilometers an hour. There was a power line torn from the poles, 1 to 2 kilometers, and it appears that the pilot was low flying on a sort of private flight with no valid reason to be low flying. These particular power lines are about 45 to 60 feet above the ground. So as I mentioned, it's not just unqualified people that illegally low fly. Our qualified pilots can find themselves making poor decisions as well, and unfortunately the results can be catastrophic. We also saw this with that aircraft that was touching the surface of the dam water as well. Qualified pilot, not on a qualified operation. The faults in the decision making are the same. So just because you are competent, you have done the training, it doesn't mean low flying suddenly becomes safe for you. It doesn't. There's still other processes we have to follow. The coroner investigated this one. They left a property. Shortly afterwards, it struck a power line, traveling at about 150 k's an hour, and the injuries and the results we mentioned before. There was no valid reason for this pilot to be flying at low level. Very sad incident. Sometimes, even when we have a qualified pilot on an approved operation, things can still go wrong because of the risky nature of low flying. In this case, it's another Robinson instructor. It's a instructional flight with a student. This is one that Phil was involved in, and he very bravely told me this story the other day. It doesn't make for comfortable reading. Phil at that stage had CPL over 2,000 hours, grade 1 helicopter instructor rating. And this was what should have been a routine training flight at Jandakot Airport. I think one message I'd like people to take away from this, there's no such thing as a routine low-level flight. All low-level flights obviously have inherent risk. So all the appropriate ratings, qualifications are there. The aircraft's approved for the rating. The operation was approved. Pilot also had significant experience in other types as well. So we're not talking about a low-time pilot here, very sling ratings, etc. Phil told me these events, and as I said, it was a very sobering reading or listening. A very warm and humid January day, some showers, so there's that little bit of drizzle around and a little bit of water on the bubble of the aircraft. It was a doors-on hovering exercise. So a lot of words there, but basically Phil was instructing the student, took control, transited forward flight, and climbed at about 35 knots to about 50 feet, and then just started a left turn. So it's effectively like a low circuit, if you like. As he was looking out to his left, where he was looking at eventually doing the landing, he realized suddenly that the aircraft was actually lower to the ground than he anticipated. In fact, so low that the left skid hit the ground and the helicopter rolled. Blades hit the ground, and as you've seen any of the videos, that once the blades hit the ground, pretty much anything can happen from that point on. The aircraft cartwheeled 2 or 3 times, which is obviously quite horrendous in itself, and then ended up on its right side. Fuel tanks ruptured, and the helicopter caught fire. Both of the pilots were able to actually escape through the front, but not before they had problems with their harnesses. They were slightly jammed for some reason, so it did take them a few seconds to get out, and they suffered burns as a result while they were trying to get out. Phil was running away from the wreckage, and he said he was shocked by the violence of the explosion of the aircraft only something like 3 to 4 seconds after they'd started running away from it. So they were incredibly lucky in this case that they weren't still in the wreckage. It was a really interesting one for the ATSB and Phil to sit down and analyse. They believe that there could have been some issue with the amount of condensation on the bubble of the helicopter that was affecting the visibility and the depth perception of the pilot. So here we have a very experienced pilot conducting a fairly normal training exercise that just got this depth perception wrong. One of our human factors, we can see there's various scenarios where that can happen, and the aircraft has just impacted the ground. So yeah, that one's just an example of, if you are low flying, approved operation, consider all the risks, do what you need to do to make it safe, with in the back of mind knowing that there's always hazards there that we need to try and avoid if we can. The last event we want to chat about is a much larger aircraft, obviously, in this case a 737. This occurred in Fitzgerald River National Park, and pilot plus co-pilot, and it's a water bomber, or fire bomber, I should say. Again, very experienced crew with an aircraft that has multiple systems on board that helps avoid these types of incidents. So we know that there's no such thing as a perfect mitigation strategy, whether it's a terrain warning system, very competent pilots, serviceable aircraft, good lookout, etc. No one of those things protects us. And if an aircraft like this, with this caliber of pilot, these protection mechanisms can fall into the trap of impacting the ground at low level, then, you know, it can pretty much happen to anyone. So this was a controlled flight into terrain scenario.
Sorry, Craig, do you have me now?
I do, Phil. Welcome.
Thanks for presenting that presentation for me, mate. I'm back online.
Fantastic. If there's anything else you wanted to add to the stuff that I said with respect to your experiences?
Look, I lost you for a while there, and look, I do apologise to everyone over here and over in the eastern states, but I thought I'd be able to add a few other bits and pieces to what Craig's been talking about, and just to solidify the fact that this doesn't happen just to low-time pilots. The two examples that Craig has spoken about involved me, one with the power line that I missed, and as he mentioned, still to this day, which has been over 25 years, I don't know how I missed that. And the other one was the R22 accident with myself and a student pilot, lucky to be alive. And again, I was a 2,000 hour pilot when that occurred. So, high time pilots aren't exempt from any type of accident. We just need to be vigilant of what's going on. And if you want to continue, or do you want me to continue with this further with the control flight into terrain with the 737?
Yeah, go ahead, mate.
Okay, so as Craig's pointed out, the 737, which was involved in fire operations at the Fitzgerald National Park, basically flew into the terrain, and the aircraft had the helicopter logistics pilot was overhead in an air attack role as the scenario unfolded. Next slide. So basically, from the information at hand, we could surmise that the aircraft was too low, it was slow and heavy. There was rising terrain ahead, and power was apparently applied after they were interviewed. But these type of engines take quite some time to spool up, and trying to get 100-ton plus aircraft up from the ground, which may have been 100 feet, it just obviously wasn't enough time for that to happen. Another thing was that they were overseas pilots and probably quite unfamiliar with the terrain. With the low flying syllabus, sorry about that. With the low flying syllabus, which is in part 61 of the Manual of Standards, volume 3, it explains how to identify wire runs and minimize associated risk with the following. Preliminary inspection of treatment area. So it basically means where you're going to fly over. If you're going to be conducting any low level, have a good look at the treatment area, have a look at the terrain, have a look at the slope, have a look at the surroundings. How to judge distance to wires? There's many ways you can gauge by how high the power pole is and try and extend that distance visually across the length of the wires to the next pole. The danger and forms of distraction. Is there any other activity on the ground that may distract you from concentrating on the job that you're conducting? Considerations have to be looked at for crossing or oblique wires, spur lines, which comes up again the next sentence. Visual cues of wire locations, such as pole runs, type, numbers, and attitude of. The insulators, the cross stress and angle of the cross stress, supplementary or spur wires or buildings. Normally on the larger power lines, insulators hang down vertically, but if there is a spur or a supplementary line, the insulators will be horizontal, indicating another line heading off to the left or right. The characteristics and dangers of high wires and guy wires. You might be conducting a radio transmitter survey, such as Telstra communication transmitters, VHF radio transmitters. Now, some of these are on very high poles, and they have guy wires. The guy wires could extend from the top way out to 150 to 200 meters, supporting the height of the wire, the tower, I should say. So, even with you being 100 meters from that mast, still puts you in danger of the guy wire that's extended from the top of the wire to the ground to keep it in place. Factors affecting misjudgment of wire clearances, which is another big thing. Crossing wires. If you're conducting a power line survey, your job as a pilot is to be looking at your job as a pilot, and that's flying and avoiding hazards, not looking at the power line. And if you are crossing the power line, ideally you should be crossing over the power pole, not the actual lines. That way you know you're not going to hit the line. How to maintain awareness of located wires. Then you need to pick a reference, whether it be a certain tree, a house, anything that will remind you of a wire that you may lose sight of. And importantly, I just recently did a presentation for our annual training with Parks and Wildlife on our burning program, and I presented the hazards of mental overload in a PowerPoint called Latent and Active Failures, which we're pilots, we're human beings, and the general everyday living, family, young children, your workload at home can mentally overload you and distract you from the job at hand, and that is knowing where the power lines are and the lay of the terrain. And as I said, it doesn't just happen to low-time pilots. It can happen to very experienced pilots, as you've seen in the 4 events. Well, Craig did most of it for me, but in the 4 events that were there, it happens to high-time pilots as well. So we need to be very, very vigilant and aware of these type of dangers when we're conducting low-flying operations. I think that about concludes me, Craig. Thanks, and once again, sorry for that little bit of a delay.
No, that's fine, mate. Stay with us for a second.
Sure.
Just going back to when you were telling me about your incident there on the training flight, you said there was a bit of a build-up to that with respect to what you were mentioning there with how fit are we to fly on that particular day. We need to analyse that. What were the sort of factors on that day that sort of led to your mental state on that particular day?
Yeah, sure. Look, the factors, look, there's numerous factors, and the presentation I did just last week to Parks with, as I said, latent and active failures. And you may, to all the listeners that are tuned in, you may not all be familiar with James Reason's book on human error or human factors, where he talks about the Swiss cheese model. And so the Swiss cheese model has 4 barriers. And if, the the barriers are there to protect us. If every error that we made actually occurred, we probably all wouldn't be alive today. However, the barriers are there to protect us, and they don't always go through the holes in the Swiss cheese, because we correct it as we see a mistake, we fix it. So that's one of the barriers. So what happened on the particular occasion for myself was, look, I'd been at the company for 6 years. In the weeks leading up to that event for myself, I was looking at a new job. I'd been looking for, we'd been looking for a new home. We'd put a bid on a home. It was unsuccessful, so I was probably a little bit disappointed about losing the home, or the home we're looking at. And on the particular day, it was mid-January, and it was quite a warmish, humid day, and we'd had some rain. So there was a chance of a bit more rain or showers during the day. So I'd mentioned this to the pilot, the student pilot, that we need to be aware of this, and the fact that water droplets on the windscreen can actually alter the depth perception of the ground by quite a few feet. So, my mind was probably a little bit distracted, even though I may have felt okay and thought everything was great. It was a repetitive action. It was something that we've done, or I've done 100 times before, low flying, low level maneuvers. And we'd gone out there quite warm. We left the doors on because we were expecting showers. The student was quite advanced. He was, he'd been solo once or twice. We were just doing some familiarization again before he's gone on a longer solo. And we've had a shower, water droplets accumulated on the windscreen. It progressed into, we need to get some air in the aircraft. I have control, and, into the wind departure. We've done this 1,000 times. Whether some complacency set in, whether I gave the student a bit more control than I should have. And as we turn downwind, which is another hazard, downwind turns give you the illusion of actual ground speed when there isn't, and there's not enough airflow over the rotor system. And there you go, before we knew it, the skids have contacted the ground. And as I said, we've been fortunate enough to escape from the aircraft and walk a few meters away before it exploded. So mental overload is also a very, very big thing we need to be aware of in low-level flying.
I think most of us listening to you, mate, who fly can relate to that. All those things stack up when we go flying. Doesn't matter what the flight is, whether it's a commercial flight or private flight, there'll be factors in our own human factors that can relate to the safety of the flight that we need to consider. And we certainly encourage people before they go flying to take a few minutes to do that. What are the fatigue factors, the mental stress factors that I'm undergoing today before I go flying? Because we're focusing on low flying today, obviously, we know it's even more important because that is such an extreme environment that we're operating in. One thing we haven't mentioned too much today, Phil, was bird hazards at low level. I didn't encounter a whole lot in the areas that I was operating in. Did you come across much of that? And were there any particular mitigation strategies used for that?
But Craig, bird hazards it's very big. It's a big hazard. Birds will occur really at any level. I mean, the operations that we conduct, particularly for parks, which is prescribed burns, whether it be with an incendiary machine dropping capsules or a heli-torch with an underslung suspended load that we use for lighting. During prescribed burns, the big hazard are eagles. You disturb their nests. They generally always fly in pairs, and they can be low level and up to quite high altitudes. Waterfowl at dams and lakes, really any bird at any stage can be a hazard. And really any flight environment runs a risk of any type of bird, particularly pelicans and eagles, which we've spotted up to 5,000 feet or more. And it's just a constant lookout when we're flying. One of the briefs to the parks personnel we have on board, that are conducting the burning operation is to be the second set of eyes or third set of eyes to look out for birds. Look, I've had a number of bird strikes, flying offshore, taking off from a rig, landing on a rig. Birds water birds such as seagulls and stuff are perched on the rigs, and as you approach, they take off, and inevitably the first place they fly is straight towards the aircraft and get drawn into the intake or into the rotor system. Fortunately, they've only been small birds, but as I said, they are a very, very big hazard, and you need to be alert to this, and not only at low level, but at high altitude as well.
Yep, thanks, mate. Yeah, also along with that, and people fly up north will know this, the flying foxes can be pretty devastating too. If you hit one of those, they tend to be active particular times of the day. So, you have some opportunity to avoid them if you become familiar with their patterns. Tristan put a really good comment in there about the risk mitigation associated with RPAS. So drones and the like. Yeah, this is a big one for us at the moment, Tristan, absolutely. Every time someone sees a car accident or a bushfire or something, they want to put their drone up to get footage of it. And in most cases, not considering the fact that we might have emergency aircraft in the area, whether they be the police chopper, firefighting aircraft, etc. The DFAS have very strict mitigation strategies. If they detect any drones in the area of their low-flying operations, they will call the operation off. CASA's got on board there, and we're doing a really heavy education campaign for drone operators to make sure they know, listen, you're not allowed to be there. You are actually putting lives in danger by restricting the operations of the rescue aircraft or the emergency aircraft. So they are something we do need to consider. We know that drones can fly up to 120 meters, 400 feet. If you're flying at the low flying altitudes correctly, you shouldn't encounter them. But also we know that some people are actually getting around those limitations and flying them higher. So a good lookout is really important. Reporting them when you see them is really important. If we get a cluster of RPAS reports, people flying illegally, we can go and investigate that and try and track them down. And the detection technology is definitely getting better in that respect too. So we've got a couple of strategies there, Tristan, to help us deal with the RPAS operations and the hazard that they present to low flying aircraft as well. So yeah, thanks very much for that question. So I did notice in the comments a lot of people had trouble seeing the photos that we were talking about and all that. Do apologise for that. Looks like Courtney's mentioned there that you can have a look at the recording of the session and hopefully pick up on those. And if you didn't see them or you can't get hold of the recording, don't worry, I've got a link to the document that they've pretty much come out of, so you can go and have a look at that document. I'll mention that in a second. So look, thanks again for joining us, everyone. It was really good of you to take your time and spend with us today, have a bit of a chat. In conclusion, when we talk about low flying, because of the nature of it, we do require pilots to have specialised training if they're going to conduct, professional or commercial low flying operations. There are multiple hazards that need to be considered before it can be done safely. There are occasions where pilots are allowed to fly low level without a rating. Obviously that takeoff, landing, and the ones we mentioned. Things where people use low flying skills include stock mustering, and someone mentioned they're mustering a paddock full of power lines, mental overload. Absolutely. I assume if you were mustering in a paddock full of power lines, a full survey would have been done, hopefully marking the power lines as well. Interestingly, when we look at the data for power line strikes, about 70% of power lines that are hit by aircraft were known about. Just have a think about that for a second. 70% of power lines that we hit in aircraft, the pilot knew they were there. So somehow they lost a bit of SA or situational awareness on where they were at that particular time, how close they were to the power lines. So it's really important we do that survey, make sure we know where they all are, and just stay well away from them, basically. For most of us, there is no need for us to low fly except for those little scenarios that we mentioned, takeoff and landing. There's some really good ATSB publications on this that I really urge you to read. ATSB's got some fantastic stuff. This is the one that I said that you can find the photos in that I was referencing. It's one of the avoidable accident series that the ATSB puts out. I've put the link in the comments. It's right at the beginning of the section there. So if you have trouble finding it, use that link. If not, give us an email and I'll send you the link. Please read it. and just realize that, you know, these decision-making processes can go wrong for all of us, and it'll help us avoid it. So in review, we talked about why we wanted to mention low flying. We discussed what low flying is and looked at the regulations that actually articulate exactly what constitutes low flying and the valid times that we can go below those heights. Then we looked at case studies that show when it all went wrong, where people made poor decisions. We looked at illegal low flying and how we can avoid that. Simply following the rules is the first major step in that. And we also looked at lawful low flying with qualified people that went wrong because of the inherent risks in low flying. And hopefully that's, if you're in that situation, that's going to prompt you to really have a look at your risk mitigation process that you use when you go low flying, and make sure you're considering all the factors that you need to consider before you get airborne. I'm glad we got Phil for at least a little bit there. Phil's got some fantastic stories and a lot of experience, and very kindly agreed to share those with us. And obviously some of them, you know, not very nice experiences, but Phil was happy for us to learn from those and take lessons from it. And we really do appreciate that, Phil. Thanks very much. Had a quick summary, and yeah, I think I've addressed most of the questions in the chat there. So if you've got residual questions, please feel free to pop them in there and I can email you back, get back to you. But thanks so much for joining us. We really do appreciate it. Hope you got at least a couple of points out of that. And if you do have any follow-up questions, follow-up comments, please feel free to contact me or any of the other aviation safety advisors around Australia via the CASA website. Enjoy the rest of your day, ladies and gentlemen. Thanks for coming.